Why you should learn it? Let's analyze this board real example. The Research and Development Department of automobile manufacturer has determined that when required to stop quickly to avoid an accident, the distance in feet a car travels during the driver's reaction time is given by the formula R of x is equal with the 3 over 4x, where x is the speed of the car in a miles per hour. The distance in a feet traveled while the driver is braking is given by, so the driver's braking is given by the formula b of x is equal with 1 over 15 times x squared. But in the next slide, we are trying to answer on some of the questions. For example, find the total, let me take one pen here, find the total, uh, find the function that represents the total stopping distance. The total stopping distance, let me write in the terms of the function t of x. So t of x is equal with a driver's reaction time, which is a r of x, and is a plus driver's braking function, which is a plus b of x. And if we want, for example, to be more specific and to write in a term of the with respect to x's, we can write this is a 3 over 4. Just let me go again and see this. 3 over 4x, yes, r over x, and b over x 1 over 15x squared. So r of the reaction, the driver's reaction time is a 3 over 4x, and the braking time is a plus 1 over 1 over 15x squared. So in this way we can write this total total function of the brake. So this is basically what we are answering on the question A. Question B, use the graphing utilities to graph the function r, b, and t in the same viewing window in the domain bit x is between 0 and 16. So if we are looking here, this you can use any graphing utilities, but in fact what I use here, I use a Desmos, and I created this graph with a Desmos. And here we will look for example, this red function represents the reaction driver's time, B represents the driver's braking when he brakes, and T is the function, the total function T of x. So those are the graphs of the function. And in the B, usually what is asking just to graph by utilities. Well, that means this utility, I use the utilities Desmos because it took me a long time to do everything, every step to show. So I just put here the graph, and I think it's not very hard to do it. Everyone can do it. So now C says which function contributes most to the magnitude of the sum at a higher speed? Explain. So now by it doesn't say, for example, in what interval is this magnitude to the higher speed. But let's say if we take this Rx and Bx and we want to find the points of intersection, one point is going to be L0 right here, and the other is going to be here somewhere. We are looking here. But to be more specific, we have to equate Rx and Bx. When we equate both functions, Rx and Bx, we find somewhere one x is going to be the 0 and other x is going to be about 11.25, this interval here of intersection. But because they are not asking, so I'm not going to find out. But if you look, for example, from 0 to 11.5 feet, 11.25 feet, the greater contribution in the total magnitude gives the function r, so the reaction time of the driver. But from 11.25 feet and further, we see the graphs of the function braking, driver's braking is greater that contributes in a total distance, in the total stopping distance. So it means the braking drivers, if we are taking the window from 0 to 60, the greater contribution gives the braking drivers, which is B of x, is greater than R of x, R of x, than the reaction time of the driver. So braking, the driver's braking is greater than reaction time of the driver. Uh, so basically this is the answer on the C. If we are looking in the longer term, and this is makes better sense.